Okay. So this session would probably be useful and speak at multiple conferences.
I have been hesitant. 60 people on the stage.
हेलो दोस्तों, तो आज जा रहे हैं गूगल के क्लाउड कम्युनिटी इवेंट में। तो कैंप पे आ गए हैं, देखते हैं कैसा रहता है आपको। तो पहला फेस टाइम फेस टू फेस ब्लॉगिंग है, तो देखते हैं क्या रहता है। आते हुए लेट हो गए थे तो मैंने कुछ रिकॉर्ड नहीं किया। बाकी तो क्लासेस वगैरह ये हैं अपने पास। बाकी देखते हैं क्या चलता है। अभी लंच का टाइम हो रहा है, तो अभी एक ओपन एरिया में बैठे हुए हैं, तो लेट्स सी। तो एक्चुअली मेरा बैकग्राउंड नॉइज़ काफ़ी था, तो मैंने ऑडियो रिमूव कर दिया। तो ये जो भी हम यहाँ से निकल रहे हैं, यहाँ पे था ट्रैक 4, वो 4 ट्रैक्स थे वहाँ पर। आई मीन लाइक 4 अलग अलग जगह सेशंस हो रहे हैं, बस यही था। तो 4th वाला जिसमें से भी हम जा रहे हैं, ये था लाइटनिंग सेशंस, इसमें कुछ ज़्यादा खास नहीं था। नीचे 3 ट्रैक्स नीचे थे, तो ट्रैक 1, 2 एंड 3। है अपना हॉल, ठीक है। तो यहाँ पे मतलब यही एंट्रेंस थी मेन, और ये मतलब लंच वगैरह वाले एरिया भी था। तो अभी ये लंच टाइम में सब लोग बाहर घूम रहे हैं अपना मज़े में। तो ये, और ये दूसरा था ट्रैक 2 ऐप मोड। तो इसकी भी सेशंस की है वीडियोस, वो मैंने डाली हुई आगे। पहले एक बार दिखा देते हैं कि लाइक ओवरऑल था क्या, लाइक कितने ट्रैक से क्या था। उसके बाद फिर मैं सबकी एक के बाद एक वीडियोस डाल दूंगा, और वो आप देख सकते हो। उसके बाद हम जाते हैं ये ट्रैक 3 में। मेन हॉल था ना, वो ट्रैक 1 वाला ही था। ओके, सो ये है ट्रैक 1। ये लोग पैक कर रहे हैं अभी सारी चेयर्स वगैरह, लाइक फॉर द एंडिंग। ओके, सो उस टाइम पे मैंने रिकॉर्ड की थी। तो था ट्रैक 1। और अब ठीक है, अब ज़्यादा बोर नहीं करते हैं। बाकी अब आगे की थोड़ी वीडियोस देख लो।
In system design, but can tag me when this question gets asked in your interview process. Okay, but anyway, so how many of you in this room are like completely new to HA or have some very little idea about HA? How many developers or aspiring developers? Nice. Anyone from DevOps? Okay. Any testing, QA? Okay. So this session would probably be useful to these folks. It's not that it will not be useful for the others, but you would find this more relatable. Okay. So with that, let's get started with designing an HA system. As I said, it's going to be a platform agnostic talk, which means there will not be any specific aspects about GCP or Azure or AWS or whatever. It can be implemented irrespective of what underlying platform is. Okay. So this is sort of like my promise for the next 30 minutes. We're going to be starting with the basic definition. Then look at the different types of the HA system. How we can use a channel, which is sort of like the heart of the HA, how we can utilize that. A crossover or a failover mechanism, as it's popularly called in high availability high availability these things. How you can monitor critical services, probing, preemption concept in terms of HA, and a floating ID, right? So, and then gonna end the thing with certain sort of like a design pitfall. Okay, so quick intro about me. I've been in the industry for some time. Currently work as a software director for software engineering at Sonic. I actually lead the GDG Cloud Bangalore chapter and also the cloud native chapter. I've got a special interest in serverless and containers. I also believe that multi-hybrid cloud is sort of like the future, and speak at multiple conferences, won multiple hackathons, etc. Okay, so with that, I'm going to set the tone by defining what exactly HA means. This is a definition that I took from Wikipedia. All of you can read. I'm not going to read this out, but look at the ones which are underlined, right? It is basically a system characteristic, right? Just like scalability. Availability is also something, a system characteristics, but usually it refers to uptime. That is, your system should be readily available. So that's the system characteristics that we are looking at. And what does it? Yes, it has to be separate. So it should never be part of your HA system. Because if you store the HA config within the system itself, what happens when the system fails? So that should be independent. So that should be completely separate out and it should be configured. Otherwise, if it's not shared, there's something called as a HA split brain. That is, my first half of the system knows something, the other half doesn't know something. So this can lead to an untoward behavior. So this is something called split brain. So your HA configuration or whatever stuff that you do for the logic of HA should be residing independently or in a common shared location, accessible to both the nodes to prevent a split brain condition. And the third one, there's a huge design difference. Whatever example that I've talked right now was mostly the active passive. The second one is the active implementation, and there is like a completely different, because both the nodes are available, both the nodes are ready to serve the request. So there should be some sort of like a different design. So whatever design that you do for active passive should be entirely different from what you do for an active design. So I guess that's it. I mean, this is the takeaway. Choose the right architecture depending on your availability. You should decide whether you want an active standby or an active. You should have a robust channel. I cannot stress this enough. Either you could do it the customized way, the way you want, by using certain programming languages, or you could use third-party libraries like PubSub mechanisms to do this, right? You need to have a failover and a heartbeat mechanism so that it is proper, and that's the reason why I asked if there are any QA or testing people over here, because proper testing is paramount to implementing HA. And there should be reliable third-party package, which can basically, so we use something called as the KeepLive, which is a third-party application. We could also use something called the HA proxy for implementation. So yeah, thanks again. I believe I have some 1 minute probably for questions, but we can take questions.
Oh wow, great. Please sir, I'll come with the mic.
Hello everyone. So first of all, Mr. Oman, thanks a lot for this wonderful session. And I see pathology, if I mispronounce your name.
Before we start, I want everyone to have like one exercise. So just everybody, can you put very hard on each hand 3 times? And check when we recommend like you deploy why this exercise is specific for you? It is just when you divert from your attention from availability to our next topic. And if you go home, then you can try the customer user journey, what this means. Then we have some concept related to SLO. I will be explaining with example how you can just correlate what this means. And then comes to the error budget. That is like where you find out balance between stability and your velocity. Then last I will be covering how you can start practicing SRE in your organization and how to get started from where you can start your SRE journey. So now comes to the main problem. So we have SRE, right? Why we even need SRE? So most of the organization we see, they have distributed system, right? And as linearly there are services or features in that services, and then there will be having ops team as well. Then they will be combined both, and they will be having responsibility who will be handling this. So there your team is working as a one team and very collaborative. In terms of like how SRE said, you have shared responsibility. It is like whatever work you do as a team, your responsibility to manage this product in the team. It is not individually tied to the name. It is simply tied to the like supposing incident manager. So incident commander is a job, but it can be done by the any guy in the team. Then comes to the accept failure as normal. So incident can happen anytime, even though sometimes you have control, but sometimes you don't have even control. So in that case, how you will be like making sure that your team have that capability. In that case, you have SLOs, service level objectives, the targets you define, and then you have blameless culture and postmortem or any reviews, sprint reviews need to be done. So in that case, you will be just trying to focus that this problem happened due to this. There was like in the checking pipeline, there was one trigger. I have just clicked on that trigger, and that's why the incident happened. But then in blameless, you will be asking why we need even that trigger. That why the trigger was there in the checking pipeline.
So DOS attack is full form of DOS attack is denial of service, and DDoS is distributed denial of service.
Okay.
Basically pinging a server to different types from TCP or HTTP or HTTPS. Basically bringing the server down and creating a virtual server. Like I'll create a virtual server myself and I'll hack that server and all the data will pass through me. Basically.
Okay.
Basically DOS means downing a server through pinging it, flooding it.
Cool. And last week on the platform community, we had this attack which was done by someone. When we pinged them on LinkedIn, they were like, no, I didn't do it because they were using a user scheme, so we found them. They were making a lot of API requests, so we finally had to block that API. So that is something people easily do. You can just go to console into any website and just run a script for clicking a button repeatedly or typing something. Not advisable, but that is the basic thing people should be around. But what happens on a large scale for Google Cloud? How do they provide those security options? That is what our next speaker will be covering on an overall basis, if I'm getting it correctly. She's a networking specialist at Google, and the title of the talk is Defense in Depth, Networking Security, Network Security Google Cloud. So let's welcome Sakshi Punani.
Thank you for giving people ideas how to do a hacking because and that. So I do realize you've had a long day here, and it's commendable that you've turned up not only on a Sunday but also on a public holiday to socialize and to maybe learn a thing or two. So I'll try to keep it light and fun. The operating word is try. Let's see. So I'm Sakshi. I'm a network specialist customer engineer. So on a day-to-day basis, my job involves talking to customers and help them best utilize GCP network, but more importantly, help them create an ironclad network. Now, before we begin, a quick raise of hands, right? How many of us here are students? How many of us here are relatively new in career, like 3-4 years experience? How many of us we do that, we need to do a complete recon, right? We need to get a fact study. So what are we trying to say here? Now Mario was trying to save the princess, but today Mario is going to help us secure the network. So in short, we are trying to secure our deployment. But the deployment on the cloud consists of various components, which are spun differently, configured differently, controlled differently. So in order to guard a thing, we need to know how the thing is configured. The simplest thing is of course the VMs and GKE, that's what instinctively comes to our mind. But these things are under your control, because you spin that VPC, you configure your subnets, and then you deploy these things. So you have a fairly good understanding of what the networking is, what's under your control. The second type of services, because the power of cloud only comes alive when you use managed offerings. The second type of service is where Google will spin a managed tenant for you, right? And then your VPC will connect to it. So we need to be cognizant of the fact that this managed tenant is not completely under our purview. And there is a third type of services which is very frequently accessed, so things like storage and BigQuery, which are accessed purely via API. So that GSUL command that you run on the cloud or any G-Cloud command that you're running, underneath the surface sends it an API call. Of course, there are other serverless products also which I'm not covering here, but it's important to understand what the underlying thing is which we're trying to say, because our deployment is not the same throughout. But what are we securing against? What is that evil guy? What is the villain in our story? Now, as the applications have evolved to a more microservices architecture, the attackers have also gone smarter. We are exposing more and more APIs to the world. So we are in threat of bot attacks, DDoS attacks, L7, LAL7 fraudulent attacks, and all that. So we know what the evil guy is out there. How have we handled this till now? Before cloud, how have the enterprises doing it traditionally? RVPC. So within this VPC network, if you look at communication from the web to the app, we're using VPC firewalls. So we've lightly clubbed all of these together, put a tag on them saying web, put a tag on them saying app, and configured rules to ensure that only the web servers can talk to the app servers, nothing else can access it. Next, we wanted to control the traffic going out of our VPC, right? That was level 2, traffic to and from. So for that, the first thing that we saw was to keep the deployment as private as possible, which means the BigQuery and GCS APIs, which you would otherwise access over the internet, now you would use private mechanisms to access them. The second thing that we saw there was to make sure that traffic is inspected, and therefore we are mirroring traffic to cloud IDs. Further, if we look at here, we have VPC service controls. This ties back to the perimeter that we saw. So this VPC network, BigQuery and GCS are in our perimeter. Anything outside of the perimeter cannot access the data which is stored in GCS, the data set in BigQuery. So note, we've eliminated the data exfiltration. Coming to the level 3 that we have here, which is exposing it to the internet. We've done that through a global load balancer here, and we've implemented Cloud Armor. We also have a zero trust IAP, which is identity aware proxy implemented. So all the traffic which is coming will first be inspected by Cloud Armor. So if we put a policy that certain IPs, certain URLs should not be allowed, they will be blocked at this point. And this is far beyond where you put your infrastructure, right? So you will only get filtered traffic onto your web server. Also, for outgoing connections, we discussed having Cloud NAT. In this case, the app services is trying to access the internet via Cloud NAT. So, to summarize, first point is, keep your deployment as private as possible. But in case that would be obvious, you want to expose some of the applications to the internet, make sure that there is very strict access control and URL access control and traffic filtering which happens at the edge itself. And third point, do not take the security within your VPC lightly. So microsegment and see what really up to what? Because, you know, as I said, content have a philosophy that we only need to guard against what's outside, but we need to have a more holistic view. So, congratulations everyone, we've been successful in our mission and we've successfully secured it.
Is the same standards everywhere. So this is done in pandas. Basically, it's a simple data frame logic that is implemented. I call it simple, but a little bit of complication. That is all Python. So that's how we are there.
The idea is taking more time. And the other questions, take them first time.
Yeah, sure.
Hello. So I also work in a fintech and we have exactly the same architecture as just mentioned. Except locally we have East or Shore. So my question is like how you continue the transactional boundary because like you broke up your earlier you were monolithic, right? So transaction were happening in the same database and everything was complete. But when you broke up, you have to maintain the transaction boundary because like a lot of services are communicating. So are you using the orchestration or choreography for that?
I was not able to understand. Let me rephrase what you're asking. Are you asking that because we are using a number of services, how do we make sure the data flow into individual services is not, we are not having any overhead in data flow? Is that the question?
No. The question is like transactions, like things are committed or not committed.
Oh, real time. Okay, sorry. So, as I said, if you look at any kind of transactions, there are three legs to it. One is there are pre-transaction activities, there is the transaction itself, then there are post-transaction activities. And if you refine all of this, 20% of your processing time is spent in transaction, everything else is pre-transaction or post-transaction. So the way we have re-architected our SDKs, which our front ends are requesting, we have parallelized a lot of it. So we do not really care if the pre-transaction activities are completing or not completing. We only care about the FRM and the limit checks, and then we go ahead. And that we have made it. We are trying to make it efficient, but then as the usual process, we added a little bit of overhead to it, but we are fine with that. And then rest of it is post-transaction activities. That happens after the transaction. For example, you going and saying to the data warehouse that this happened. So we are okay with that getting a little bit delayed. So we optimize on the transaction engine, and the optimization has come by dividing it into multiple pieces, by being very sure what tool we use. Like I said, initially our transaction was being done on a relational Oracle database. Today it is not done on that. It is done in a Cassandra database. In Cassandra, we have about 60 nodes that we run, which is much faster in terms of write speed than Oracle. It is slower in terms of query speed, but we do not query it at all. We post the transaction, we put it into a warehouse in BigQuery, and we query data from BigQuery. So that's how it changes.
Thanks.
Sure. Thank you very much. Thanks for your time.
We will definitely going to connect. Thank you for sharing like the whole journey. It was really very awesome to know that all the things that you have done, and on the payment side that is very important. And he has came all the way from Bombay. Yeah. So a huge round of applause for the things like him.
A huge thank you for being a patient audience and listening and being interactive with all the speakers. And this is not exactly the end of the day. We have a huge group picture today, and we make you meet the team and everyone after this. This partition that you're looking at between this call and the next call, yes, it can be. And this will become one big call wherein everyone will be gathering. So we have a quick tea break, and the time right now is 15:57. So we'll meet again back somewhere around 4:15 to 4:20, and we'll start the ending keynote at 4:25, wherein there will be everyone who has attended the event today, with all the speakers, all the volunteers, and we'll do some feedback, group picture, and then after that the most important thing, which is that. Right? Okay. Cool. I'm sure no one here is for swags, but yes. Yeah. 60 people on the stage might be a little bit of a difficult task. So let's get half people here, and within 2 minutes, let's quickly get that picture done. Right?